A very good afternoon, everybody. We are working with the transaction system in database management system. Today we are going to work with ACID property of transaction. In our previous chapters, we have discussed how a transaction takes place from one account to another, and to prevent the failure in transaction, we have commit and rollback. These two methods are implemented if there is system crash, connectivity problem, or due to some internal error on the server. But to make the complete transaction secured, we need to know, learn, and implement the ACID property. To ensure the integrity of data during a transaction, a transaction is a unit of program that updates various data items. The database system maintains the following properties, and these properties are widely known as the ACID property. In ACID, A stands for atomicity. This property ensures that either all the operations of a transaction reflect in database or none. Now let us take an example of banking system to understand this. Suppose account A has a balance of $400 and B has $700. Account A is transferring $100 to account B. This is a transaction that has two operations: debiting $100 from A's account, creating $100 to B's balance. Let's say the first operation passed successfully, while the second failed. In this case, A's balance would be 300, while B would be having the same $700 instead of $800. This is unaccepted in banking system. Either the transaction should fail without executing any of the operation, or it should process both the operations. The atomicity property ensures that either all the operations of a transaction reflect in the database or none. C in ACID stands for consistency. To preserve the consistency of database, the execution of transaction should take place in isolation. That means no other transaction should run concurrently when there is a transaction already running. For example, account A is having a balance of 400 and is transferring $100 to account B and C both. So we have two transactions here. Now let us say these transactions run concurrently and both the transactions reach $400. Now in that case, final balance of A would be $300. instead of $200. This is wrong. Now, if the transaction were to run in an isolation, then the second transaction would have read the correct balance, 300, before debiting $100 once the first transaction went successful. Isolation. For every pair of transactions, one transaction should start executing only when the other finished execution. In our previous consistency section, we have already discussed this. One transaction should run one at a time. No concurrent transactions in the same account is possible. D stands for durability. Once a transaction completes successfully, the changes it has made into the database should be permanent, even if there is a system failure. The recovery management component of database system should ensure the durability of the transaction. Now, all these four parts, atomicity, consistency, isolation, and duration, covers the acid property of transaction. Now, in our forthcoming chapters, we are going to read out and go through the transaction states and deadlock in our forthcoming chapters.